My name's Kyle Egbert. I'm a graduate student. I'm working with Jody. Matt Yost is my advisor, and Neil Allen and Earl Creature also on my committee. And so my project is we're looking at different irrigation scheduling strategies and demos. So I'm just going to introduce the project and kind of give a little demo of these different things. As you can see, let me just get rid of this. As you can see, we're working with Meter, some technology from Meter. We're also working with Fieldnet and Fieldnet Advisor. And then this guy down here is our irrigation scheduler. I just want to double check. Jody, can you see everything I'm showing?
Yes, I can see
Okay.
Your shared screen looks good.
Okay, perfect. So as we're very familiar with, Utah is a dry, arid state, and drought is very common. We pulled this off of the drought monitor, that image on the right in 2018. Each one of these individual circles just is showing the general region of where we have fields work. We've been working with 12 cooperators, 12 producers in central Utah, in Millard, Sanpete, Sevier, Beaver, Paiute, and Wayne counties. So what we need to do is, these different water conservation districts need to find solutions to help producers conserve water and get that water to stretch as far as they can into the growing year. There's a lot of different methods, water saving technologies out there. There's LIPA, there's LISA, Dragon lines, drip systems, whatnot, but a lot of them are fairly pricey, and that can be a good deterrent to growers to not adopt those practices. And so kind of the way that my project came about is extension surveys found that very few producers use some sort of data-driven irrigation scheduling or using that data to determine whether or not they need to irrigate in a specific area or in their whole field. And then also too, many producers do not maintain their equipment as well as they should. And this is something that I found to be the case. And I'll talk about both of these kind of in two separate sections. So our objective was, or is, to find strategies that have the greatest potential to optimize water and get it to stretch as far as possible. However, we have a strict condition that these strategies or these technologies or these methods must be easily adopted by producers. We don't want to overcomplicate things, and we don't want things to be too pricey. Again, we're trying to incentivize this adoption. So what we've done is we've deployed a couple of different things. So here on the left, we've got sectional irrigation scheduling, where we're looking at soil moisture, we're looking at evapotranspiration, or how different variables in weather is affecting the crop water need. We're also looking at a commercial model, and then we're kind of comparing all of these back to the conventional methods that the producers are using on their individual farms. And we're combining those sectional schedules or those sectional treatments with some equipment treatments. As you can see here on the right, we have a little pivot span. And what we've done is we've divided the span into 3 sections, where we have existing equipment in our first section. And this equipment ranges anywhere from being a year old to 20+ years old. And then we've gone ahead and we've put in a new section of drops, sprinkler equipment, that is what is designed for that pivot, according to the flow and according to a couple of the other factors. And then we've also put new equipment that has some smaller nozzles so we can restrict flow by about 10%. So in 2019, the layout that we had was something like this, where we had these 4 sections, and where we were looking at soil moisture, evapotranspiration. This is supposed to say the commercial model, and this is supposed to say the conventional model. I goofed that one up, but we divided it into these 4 sections. And within these 4 sections, we just went ahead and we put in 4 treatments. I think Matt's going to talk a little bit about the data from last year, but inevitably what we wanted to do is we wanted to randomize these plots, and instead of them being right next to each other and kind of sequential, we wanted to randomize things a little bit more for this year. So this is what we did. So we took the randomized schedule, so we have 4 of them, and we replicated them 4 times. You can see all these different bands with different colors. What ended up happening is we randomized it through some software and then laid it out on each individual field. So these bands of colors represent how those, whether it's soil moisture, evapotranspiration, or commercial model, or the grower's conventional scheduling. And then we overlaid that with these boxes here representing the type of equipment, whether it's the old equipment, the new equipment, or the new equipment with a 10% reduction. So in total, we have 48 plots in each field. On the equipment, again, this is just showing it, how we divided the span up into 3 different sections with existing equipment and rates, the new equipment, and then the 10% reduction. So these are some of the things that we found as we've gone out into the field, and as we've replaced equipment, or as we've spent time doing harvest. And this is a good representation of what happens when a lot of gunk gets through your filters, your screens, or even if you're not filtering and screening, that's all coming through, plugging up these regulators, and ultimately plugging up these the nozzles and whatever type of pad is on there. You can see that that spinner disc in there cannot perform properly. It cannot spin and cause an even distribution of those water droplets onto the field. This one in particular there on the right, you're getting nothing. That's basically just like a soaker hose, and you're not getting any kind of pattern out into the field. The other thing that we found is these regulators over time will fail. I ended up designing this little machine, this contraption here, that basically what it does is it looks at, you put a pressure regulator into it, you have your incoming pressure, your inlet pressure coming in, and then your outlet pressure coming out. And what this does is it checks to see the functionality of those regulators. It checks to see if they're working properly. In some instances, I found that these regulators had failed entirely, that they weren't regulating, and that the seals inside were broken. And so we get this pattern that comes out of, this is a Nielsen regulator, but you're not getting any sort of regulation through that piece of equipment. It's really easy, as we can look at this picture on the left, we see that sprinkler pattern there. If we're just driving in the pickup down the field, it's going to be very difficult to see a failed regulator like this that matches the spray pattern of that disc like that. And so, you know, getting out, walking the field, seeing those pressure regulators is really the only way, getting up and close, though, really the only way you're going to be able to identify that. Just real quick to mention, the 12 farms that we have, like I had said, we're working with equipment that's a year old all the way up to 20 plus years. And in fact, the grower of that pivot doesn't really know exactly how old those pieces of equipment are, because they received or inherited that pivot and had not changed the equipment in the whole span of time that they had owned it. Here, down in here, what we ended up doing is this regulator that was put into the contraption, I ended up cutting it in half and looking at the O-rings and the diaphragm to see what was going on. And as I had mentioned before, they had failed. So effects of failed equipment. On the right, you can see the measuring tapes. This is from one of my fields that actually has this problem. Within the first part of the span where it's the new equipment, we weren't getting an even pattern and an even application of water. And so the growth right before harvest was only about 12 inches. Moving just 50 feet down the span where we put in new equipment, same amount of time, pivot spent the same amount of time walking over, applicating or putting inches on, we're almost to 2 feet. In fact, it looks like we are at 2 feet here. So essentially we've doubled our yield just by taking care of the equipment. There on the bottom left, it's a severe case of what equipment malfunctions can do. So the other thing, and we're getting more now into scheduling, and what's happening here is we've gone in and we've put in soil moisture sensors into the field, and we wanted to look at how what was going on in the soil in each individual field. So we put sensors in at different depths. Some of them are only 0 to 3 feet. Others are 0 to 6 feet. And this just shows a little bit of the programming that I'm going to get into. I'm going to do a quick demo here. So I've got to fly through this. I've only got 6 minutes left. And then we're looking at evapotranspiration and just what's going on in the weather, how much the crop is using in water. We're calculating evapotranspiration. And then commercial models through Fieldnet Advisor using Zentra Cloud to calculate how much water needs to be put on. So what I'm going to do now is I'm doing this online demo. So this is the Zentra Cloud, the program by meter, and this helps. This is when you log in, you see all your different fields where you have data loggers set up. You can click on one of those icons and it's going to show you each individual port, how many inches per foot of water you have wherever that sensor is placed.
Kyle,
yeah.
We're seeing a maintenance checklist. I think you're trying to show the Zentra Cloud.
A maintenance checklist.
Yeah, that maintenance checklist. Maybe try doing a new share and pick your.
There we go. There we go, Matt. Can you see that now?
Yes.
Okay, perfect. So what I was saying is coming in, logging into the Zentra Cloud. This is your soil moisture sensors. It shows where each one of these data loggers is located. When you select an icon on one of these data loggers, it'll pull up and it'll show you how much water, we have it set in inches per foot, is in that soil profile. And so the problem with this is all great and dandy, but the problem is that we need to understand what our water holding capacity is in this soil. And so going through and looking at the data from the time that there was a watering event to the next watering event, we were able to identify where this number sits at. So I will pull this up and do another share, a new share, and show this. So we put together this water calculator, and this shows the field capacity or the water holding capacity of each port on each field. And then what we're able to do is we're able to put in the actual number, and we're able to calculate how much or what percentage, how full we are in that field. And then if there's a deficit, it can tell us how much water we need to put on, or if we have a surplus, we know how much water that we can basically extend that irrigation, or maybe go a little bit lighter on the irrigation the next pass, let the soil dry up a little bit, and then on our next pass go a little heavy. So go back to our, so in coming into this is really handy, and that's really an on-site and site-specific method of looking at our soil moisture. The next method that we're doing is Irrigation Scheduler, where we're able to go in and we're able to put in all of our different fields, and in the settings, we're able to connect to our nearest weather station. And when we do that, we're able to look at the water deficit. And I'll show the daily budget table real quick. Actually, it's the water chart.
We're down to about 3 minutes, Kyle.
Okay. So in our soil, looking at our soil water chart, this is handy. It shows us our rain events in blue, these blue squares. It shows our irrigation events, what we're manually putting into the program. It shows us where our first stress level is, and where we've killed the crop, and where our full soil profile is at. And then as we're going through the season, it's going to show these peaks and these valleys of what the soil water is doing on that individual field. This is a method that we can do. We can come in here and we can see how much inches of water our crop needs, so that we're not stressing it. We do that in the dashboard. I can come in here and say, today I irrigated 2.5 inches. It'll save it. At the end of the day, let's see, let's go back in. At the end of the day, it'll recalculate this, and so we'll have a deficit of 2.3 inches, and that's how we're able to monitor what's going on in our soil. This Irrigation Scheduler mobile is taking into account weather as far as how many inches of rain we're getting, what the wind speed is, the direction of wind speed, our relative humidity, crop growth stage, and different factors like that in order to calculate this number. The last method that we're doing is this Fieldnet Advisor, where we're able to go in. We have all of our fields that are connected to it. It shows us the current status of the field. But what we're able to do is we're able to go in to our field and set up a plan. This is how we've been able to do our different sectional irrigation treatments from Logan. But here on the majority of the field where we don't have plots, that's just what the producer is doing, how many inches they're putting on. The rest of it, as you can see here, is we're putting on different depths. And what this program does is it takes into account a lot of weather information, and it also looks at what type of hydraulic properties there are in the soil, or rather how much water that soil can hold and what the infiltration rate is. So this is just one of the other methods that we're able to use in order to watch how much or what's going on in our soil.
Time to wrap up, Kyle.
Okay, so get back into here. The last thing I just wanted to show is this pivot maintenance checklist. Everyone can go to this link down here, cropwatch.unl.edu, to check out that checklist. And are there